Thank you for this invitation. I'm very happy of being here with an idea of interdisciplinarity, because I think this is a word that is giving sense to this meeting, because I'm not a mathematician. I am a geographer, but I have a background on arts, a PhD on Markovian models. I'm lecturing GIS, and I'm used to work as a freelance on planning, attending to demographic issues, social issues, things that are related to history of land. So this mix of things, I think, is important in order to understand global changes. Global changes are nowadays a new point of view of any issue related to science. So a new point of view, in many cases, is more important than a mathematical model or an epidemiological or biometeorological model. A new point of view is a new approach. If I move in this room, and now I teach from here, or I speak from here, you will have a different view of this room, even if you are in the same room, but this is absolutely different. So in this new view, you will probably find something that is going to be useful for the traditional view. And this is taking place in science constantly. Okay? So first thing, I will introduce with 2 slides this society, the International Society of Biometeorology, that is an interdisciplinary science studying the interactions between the atmosphere and living organisms. Okay? That's the main aim, and it's 60 years old. So it was created before climate change became many headlines on the newspapers. So there were people caring about these interactions. And we have a bulletin, and we have an international journal that has an impact factor, is really good. And we have international meetings every 3 years. So, and also we have different commissions, that are active commissions. Some of them are here, 6 of them are here, and one is a Phenology Commission. We have a Climate, Tourism and Recreation Commission, a Universal Thermal Climate Index Commission, an Animal Biometeorology Commission, a Biophysics of Adaptation Commission, and a Climate and Human Health Commission. So this talk will be mainly focused on what we call health warning systems. There are people working on this Climate and Human Health Commission on the development of using meteorological data to forecast the impact on people's health of atmospheric changes. Okay, so you are very welcome to join this society. If you are a student, you get free access, and then you will have free access to the international journal too. So this is the aim of this society, and we would like to become more interdisciplinary. We need people from other disciplines to join us if we want to improve our works. So, well, before starting the presentation I want you to think about the world. I suppose you have a car. For some of you, how many kilometers have you driven with your car, or miles? Mine is 72,000 kilometers.
Mine is 200,000.
200.
Very old car. Yeah.
So you know how many times you have driven around the world? 5 times. Yeah, you have to drive 42,000 kilometers around the world by the equator line. So then you have a different idea of the world. No? So if you think how big is the atmosphere, is it big? Is it small? What do you think? This is the Earth. Okay. And this is an egg. Okay. An egg. Fried egg or? Okay. So, if you look at the radius, the Earth and the egg, there is a proportion, and the crust of the egg is the same size in this proportion than the Earth's atmosphere. So, is it weak? Is it strong? What do you think now? The approach we have is going to give us the result. So if you want a different result on your research, you have to change the approach. Otherwise, we will reproduce traditional methods. Okay? It's a kind of revolution. But it's not just a word, revolution. Think about the Earth and think about the main revolutions on the Earth. No, not challenging, just about societies, about people. For instance, agriculture revolution, or industrial revolution, or French Revolution. Quick changes. Which one is the nowadays revolution? Global changes, technology and digital revolution. We are inside of this revolution, and we are not aware of this. It's the quickest, the fastest revolution we are suffering as human beings. Yeah? And we are inside. So we have to be aware of these issues, because a country that is moving fast into these changes will be leading the world in 40 years' time without suffering industrial revolution or social movements and so on. That's a point in relation to this idea of technology because of the title of this presentation. Biometeorological data infrastructures and early warning systems based on geographic information technologies and mobile devices. Plenty of the idea of big data technology, information, right? So, but this is about the atmosphere. So this is the index. I will go through the idea of the atmosphere as a risk for all of us. Then we will mention a biometeorological model. It's being developed by Cuban people years ago. And then we will show one specific biometeorological early warning system that is working on this application. You have there Oxyalert beta that is free, available for any mobile phone with an Android system. Okay? And if you want to download it, you only have to register and you will see it, how it works while I'm telling you how it works. So, first thing, is the atmosphere a risk for us? Well, it depends if we speak about weather or climate, two different concepts. Okay? Weather is how the atmosphere is today, but to speak about climate, we need at least 30, 40 years of daily data, an average of daily stages of the atmosphere. So, in this sense, we have two types of impacts of atmospheric changes on human beings or in living organisms. One related to weather and another one related to climate. If it's sunny, it's really hot, it's cold. Are you meteorosensitive? Do you feel these changes? If it's cloudy, how is your mood? If it's not cloudy, you feel happier? What about snow? What about rain? Is the rain changing your physical stage? What about windy? Is it wind? If it wind can provoke impacts on your behavior? Many things. One factor, only one factor, can be very important, right? Only one can be enough to change the way you feel. But climate is different. The impacts because of climate change are related to these big domains we have on the Earth. Okay, we have a Mediterranean climate. In Spain, we have Mediterranean climate, like here. So this is a domain. We have Atlantic climate or oceanic. So the impacts related to climate change will be different and will be a matter of distribution of many things on the Earth. So atmosphere can be a source of damage. Direct or indirect impacts are possible, right? So speaking of climate change as one of the most important global changes, but it's not the only one, we have big uncertainties and statistical uncertainties and epistemological uncertainties and methodological uncertainties, many different uncertainties, but we think that extreme events are going to be more frequent and more intense, like heat waves. So we have risk number one, and we also have changes because of physical parameters changes. We have new environments, ecosystems are changing. There will be probably emerging diseases. A new disease will appear somewhere where it wasn't before. It's a different type of risk. But we also have weather variability, the forecast, where uncertainties are lower. Each day the forecast is better for 2-3 days in advance. But this weather is also having anomalous variability, but not extreme, that is affecting people and living organisms. Okay, can you see the differences? So, but risk from geoscience, speaking about geoscience, it's a complex problem. To get risk, to be risk, to have a risk, we need a, speaking of hazards, we need an impact of something. We need to be exposure to this impact. There is no risk if we are not exposure, and this is very related to space where we are. And we need to be vulnerable to the impact. If I'm not vulnerable, even if the impact is very big, I don't care. There is no risk. Okay? So, and also, resilience is becoming an important word in terms of I can suffer it, but I get over the impact, there is no problem. But this is also a relative concept, all of them very related to the place on the Earth where we are, okay? And also related to how meteosensitive you are, and which is your biometeorological profile in this sense, right? So it is a risk. I think it is a risk. Could you please stop breathing for 1 minute? Would you be able to stop? We'll try, okay? 1, 2, 3. Come on. You couldn't do it? So is the atmosphere a risk? What do you think now? I'm speaking about oxygen, one factor. It can be a risk, okay? So we know that weather and meteorological variables are affecting hormonal functions. We know that they are affecting our neurotransmitters. They can alter cerebral biochemistry. They affect to vasodilatation. They can modify capillary resistance and many other impacts. We know this, but we know very few, about the specific mechanisms that make a specific atmospheric factor become a risk for each person. Okay? So but let's think in one specific factor, like temperature in this case. We are using on biometeorology a specific definition of health. Here it is. We consider health is the aptitude of any human being to conciliate their vital functions with climatic and meteorological variability and change without compromising people's well-being. We are constantly suffering health crises. This is our approach now. It's warmer here now than this morning. Have you realized? It's darker than this morning. Have you realized? We are constantly suffering this health crisis, right? Okay. But we are healthy people, so our body is working to be balanced, right? But for each factor, we have this function in which, according to the exposure we have to the temperature or sun radiation, for instance, if we get few sun radiation, some people might have problems of rheumatism. But if I get too much sun radiation, I could get skin cancer. So there is always a comfort area where the risk doesn't exist. But if you move to the right or to the left, your body will suffer a different stress, a negative stress called distress, right? So this is why this negative stress is going to be important in our biometeorological models. Mm-hmm. Because when there is this negative stress, the body will start to use thermoregulation to keep the balance. So this is taking place in a short period of time, constantly. Or if you travel many kilometers, then there is a process of acclimatization. So the time here, time scale is going to be short or medium period. But we also have longer periods of adaptation to these changes, and this can be a biological process, or in some cases is a cultural, infrastructural, and technological process. Or we can migrate to avoid the impact. So these are strategies we have to avoid suffering this distress. We are not able to get over it. So it's like going to the mountains, to a very high elevation. Have you been at 6,000 meters high? Sometimes. You like mountains? You go to the highest peaks? Have you been in the Himalayas, or in the Alps, or in Kilimanjaro? No? So people who like visiting these places, they know how important oxygen is and the impact that changes of the partial density of the oxygen in the atmosphere is to survive, right? So we know this when we speak about mountaineers, but have you thought that a similar process could take place at the horizontal layer of the atmosphere. This is the beginning of this biometeorological model in which oxygen contrast impact can provoke biometeorological distress and is going to put people under an important risk based on these changes. And this is the unique formula I will present here that was developed by a Soviet researcher, Russian researcher, many years ago, Dr. Oxyalert, based on the main laws related to gases in the atmosphere, and also was adapted to the biometeorological interpretation by Dr. Luis Lecha from Cuba, and is using only 3 parameters. Okay, 3 parameters. One is temperature, air temperature, atmospheric pressure at surface, and water vapor pressure. Okay, this is a formula that was developed attending to the physiological impact of changes. Okay, not for meteorological issues. Okay. So based on this model, okay, we decided to calculate it for different places in the world, right? Using information from the global forecast system from the United States and computing this model every 6 hours, right? So firstly, there were 3 different thresholds of the impact of these changes. Okay, you can see here extreme hyperoxia, very strong hyperoxia, strong, moderate, weak, neutral zone, weak hypoxia, moderate hypoxia, strong hypoxia, very strong or extreme. Hyperoxia is when there is an increase in 24 hours in the amount of oxygen in the atmosphere in grams per cubic meter. Okay, how many? And hypoxia when there is decrease on this amount of oxygen in the atmosphere. And these are the thresholds for low latitude, mid latitude, and high latitude that were used initially by the Luis Lecha, the professor who created the model with his team, right? And through the Climate and Human Health Commission at the International Society of Biometeorology, I proposed to validate this model at different places in the world. Okay? This is something we usually do. If you create a basic model, you share it, and members of this commission, we will try to test it in our locations. Okay? And I did it, yes, in the north of Spain, a place called Bilbao, in the Basque Country, and because I was able to obtain information from one hospital for 3 years, and I was able to obtain information about the number of people who were attended at the emergency room in relation to brain vascular diseases, to headaches and migraines, and ischemic strokes, right? So, and we were looking for, these are the dates, 2005, and this is the change in grams per cubic meter, increase or decrease in the amount of the partial density of the oxygen, and these circles are representing the number of people who were attending in the same day or 1 day after, in the same day, 1 day after, in the same day, 1 day after. And these circles are representing a percentile over 66, right, percentile. So, and in 3 years, we realized that something was going on. Just looking at this. So, okay, we had something, but we wanted to develop then a biometeorological early warning system based on this idea. And we found some problems, that many of the approaches we have for these early warning systems are based on local data. We have the problem of spatial variability of meteorological data. If we include physical factors in the growing of a plant, then variability is the growing will depend on physical factors. Even if the model is right, if there are no physical factors in the model, we will not use it in the future. There are uncertainties on forecasting models, but we decided to use some variables that are not so uncertain, like atmospheric pressure is a good variable in this sense. Rainfall would be much more difficult because of the variability and there's uncertainty of the forecasting. And vulnerability is not defined at personal level. This is an important issue. If we are working with the average, I don't know what's going to happen to you or to you. So we want to know what's going to happen to each person, and each person has a different vulnerability and exposure where we are in the world. So we decided to attend to these issues in order to develop a technological platform, okay, where we could use information from big servers, European Center for Medium Weather Forecast, NCAR, Global Forecast System, and also with this innovative approach in order to define biometeorological profiles for each person and looking at the geolocation of people, right, where they are, and using geographic information technologies like GIS, GPS, right, and mobile phone technologies. So it was very ambitious, so we decided to create this technological platform. There are two sides here. This is number one, we created a server. This server is using information from the global forecast system every 6 hours to produce the biometeorological model, and we defined and created a mobile application, okay, only for Android system. We didn't have too much money, so we couldn't do it for iPhone. I'm sorry, but at this point only for Android. So the process was to download the variables automatically. Now it's working in my office and is producing the biometeorological model. This model is, this is the computer, is producing every 6 hours a global map of oxygen in the atmosphere, okay, grams per cubic meter. And this has been working almost for 1 year. So we have the maps for the last year, right? So this is the first part of the platform. This is the process, the data hour. It's automatically creating directories, looking for data in the global forecast, to create links to download information, to decodify the format, the grid format, where meteorological variables are, to read data sets in arrays, to calculate the index DOA. This is from Spanish, oxygen atmospheric differences, to split results in files, and to save atmospheric oxygen for date and hour. So that's the process, and this is an example of one map, global map, okay? You see the scale here, 352 grams per cubic meter, 133.5, because this is automatically produced. But this is more important. The difference is every 24 hours at 12. This is a sequence of, I think, 6-7 months of the differences. Okay, here's 2015, is April last year, okay, 16. And as you can see, these are the differences, and different colors are telling us where the hypoxia and hyperoxia impacts were taking place, right? Okay. And also we are producing these kind of website maps. You can click in anywhere, and then you get the variation of the oxygen in the air. 2 days ago it was 1.6 grams in 24 hours in Cape Town. And on the other hand, we were creating the mobile application. Okay, so we get the biometeorological forecast of hypoxia and hyperoxia conditions 7 days in advance, and we get it in our mobile phone. If you have downloaded it, you have to click only one switch. Since yesterday at this time to today, there is a decrease of 4.1 grams per cubic meter in where we are, right? So you know constantly, at any time, the difference in 24 hours in this case. We could calculate the difference in 12 hours or in any period, 18 hours. Or so the thing that this is going to give you, the app will call, if I click here in the app now, I'm calling to the server, I'm transferring the X and Y coordinates where I am right now. The server will look for this information in the maps, this position, and then will transfer this information to the mobile automatically. And then these are values that the mobile phone is going to use to present these graphs with the increase or the decrease every 6 hours in the following 3 days. And this is the oxygen line for the following 3 days. And according to the thresholds, we'll get an alert. And this is an example of the extreme hypoxia we suffer in Spain, in the place where I live, of 26 grams per cubic meter, April last year. We were really impressed. It's been the extremest alert. But the thing is that we were very happy because it was the first red we got. And then these changes are relative. They depend on latitude. So in this particular case, in Santander, where I live, we were very surprised because one day after, this is the newspaper, regional newspaper, there was a big problem in the main hospital because the emergency room was collapsed. And the head of the hospital couldn't explain why. It was on Monday. Monday, usually there are more people, but in this case, they couldn't understand. And pathologists that were assisting, went to the hospital were very diverse because of the general unbalanced of people who are old or who have chronic diseases. So it's not a direct impact, but indirect. And we were really surprised with this news one day after having this huge impact. So it's not a coincidence. So we were proving that something is going on in relation to these changes of oxygen at the horizontal layer. And these changes, of course, for a Canadian, 20 grams is nothing. For people who are living in the tropical areas, it can be a lot, impossible to. So because these changes are relative, okay? So they are corrected by latitude, okay? And this is taking us to the main idea, not having this early warning system, but collecting information using this early warning system to improve it in terms of creating a customized early warning system for each person. Because when you download the application, you are going to tell us your name, when you were born, gender, weight, height, the place where you live since you were born till you were 12 years old. This is very useful to define your biometeorological profile. And if you have the following health issues, migraines, circulatory problems, hypertension, respiratory problems, when you download this app, you are telling to the system this information, and this is going to be stored on a huge database right? So it's for Android, not for iPhone yet. It will be soon. And so with this application, let me check one thing. Yes, when you register, you give us this information, and we were looking at the first 100 days of people using this, okay? And this is a beta version. We have to improve some things. But the thing is that there were 387 users in 100 days. We haven't promoted. This is our friends and people who know that this has been done. 217 male, 170 female. And this information is stored in this database. This is part of the technological platform. We keep this information here. And for only these people, the users, for 387 users, none, with no problems, there were 167. There were people, poor people, they have migraines, respiratory, circulatory, and hypertension problems. There were 6. So this is the information we receive about these persons and where they are located, because we have the X and Y coordinates. So this is a very important information for spatial analysis and to know how geographically these impacts are behaving, okay? So we have not only the X and Y coordinates, but we have the postal code, or we have other types of geolocation that is very important nowadays, like Google is doing with the flu trends, as you said before. There are different ways of geolocate people. And what is more important is we wanted to know if the users use the app requesting biometeorological forecasting. And the daily mean of request was 8.8 per user. You know how many times my students start WhatsApp in one day? The average? You wouldn't believe it, 173. That's technological revolution. This is the world in which we are now, okay? An average. So, is biometeorological forecast demanded? Of course it is. So, but when there is an impact, and you get the red or the alert in your mobile phone, automatically there will be a questionnaire asking you if you want to fill it. Like, in general terms, how would you say your health is today? But compared to yesterday, how would you say your health is? Do you feel some muscle pain? Do you have headaches? Do you have problems related to respiratory? Do you have circulatory related problems? How did you sleep today? How do you feel emotionally? Cancel, snooze for 24 hours, send feedback. And this is what it is really important for us. There are people who are filling these questionnaires. So each time there is an alert in the place where they live, all around the world. So we are registering this information, and this is very useful in order to assess our model and to reformulate. Yes?
So for a variable, like how do you feel today, how are you measuring it? Is it
Yeah, there are each question. Let me start the app. This here, real time. Each question, now if there is an alert, for instance, I get a red light, and then the questionnaire is here, right? So the first questionnaire says, do you have headache? You have 3 options: no, some, heavy. Or do you feel, did you have circulatory problems? No, nothing regarding this. Yes, slight intensity. Yes, moderate intensity. Yes, elevated intensity. So there are 3, 4, 5 possible answers to each question. okay? And this is codified, and it's put in on a database system, relational database management system. So this is what it is important for us in order to know how to modify our biometeorological model and also to improve it and to confirm if it's working or not. Maybe we have to change it, right? But collecting information is going to be essential in this way because we know exactly where this impact is taking place, X and Y coordinates for each person. And at the same time, these are results of these reports of these people in the first 100 days, telling us that general health, there are 5 levels in the answers, muscular pain, 3 levels, but 21 users were suffering level 3, the highest, in relation to these 3 levels, with different impacts. We have also registered the impacts, when and where. So this information can be very useful because it's the feedback from the users in the place where they are for a specific impact. And this is recorded here. So the thing is that what I consider it is important in this case is the technological revolution as a tool to move towards knowledge society based on digital data set is a must nowadays, okay? Because it's not just we have a tool to validate a model, because the tool is going to give feedbacks to improve the models, and it's going to be able to transfer data into new information and new knowledge. And this is a revolution in science. So in this sense, any early warning system nowadays should be based on co-design and participatory design, including other disciplines and people, okay? So that's the way we have to work now if we want to get new knowledge about reality, right? And this is a list of the future activities we want to develop, because this is an open project. You are very welcome to become testers of the application, okay? And to tell us things that are not working fine, as some people are doing, and we thank them a lot. And next step will be to contract a community manager and experts on social networks in order to make this a viral application. We need access to medical data. That's very difficult to obtain because we need to validate the models. And if there is no medical information, there is no way to validate them. But privacy of these data sets is something that is not easy to obtain them. We need to get more knowledge related to vulnerability, okay? Defining customized risk, defining your profile, your biometeorological profile. I'll give you an example. If you take meteorological data from the place where you were born, and you take 12 years, and you look at temperature, and you see which was the highest and the lowest temperature you were experienced in this period of your life, and you consider that this is the threshold in which your immune system was developed, and suddenly there is a temperature that is far from these limits, you will suffer an impact because you are not used to it. Your immune system is not used to it, a basic idea, okay? In order to define your biometeorological profile, attending to each factor, right? So we can put this in the model and in the system. We need to increase spatial and temporal resolutions of meteorological information, and users are asking for advice. Users of the app, they are emailing us, they are asking for advice. What should I do in this alert? But we are not medical doctors, so we don't know what we have to answer. But they are asking for advice. So, and linking the research not only to the medical community but to other scientific communities, like the biological one, epidemiological one, mathematical one, statistical, and so on, right? So, and I was in the flight just modeling South Africa for the last, from the 1st of April to the 15th, and I found that changes at 12, from day 5 to 6, got a very important difference on the partial density of the oxygen. You can see here from minus, the change was from minus 10 in some areas to almost 20.6 in others. Different in 24 hours, from day 5 to 6. I'm sure this took an impact in those places where changes were of hypoxia in relation to respiratory diseases. I'm sure that if you go to some hospital where this color is on the picture, well, not here, well, and you check how many people were attended, that's the way we would like to validate this system. Okay, this is a continuous representation, but this is going to be you will get it very easily once we finish to install this system to produce automatically the maps on our website, so I will let you know. And that's all I wanted to tell you, right?
Is there any relationship between these delta oxygen and fire risk?
Fire?
Fire.
Yeah, we don't know it, but the thing is that we produce the map of the oxygen, but this can be used for many purposes. We are using it just in relation to hypoxia, hyperoxia conditions, but this can be related to so many things. And that's the ability, and this information is available for you if you want it. We have 1 year and 3 months, I think, of maps, grids, every 6 hours. This can be related to probably vegetation production, CO2. This can be related to interdisciplinarity. It's going to tell us the use of this information. You were asking something that probably is very related to fires, I'm sure, yeah. That's the point of this meeting, looking for new ideas related to what one person is presenting here. Very good question.
Other questions? We may come to discuss over the break, so thank you very much.
Okay, thank you.